with Archimedes principle, right?
Yes.
In fluids. Okay. So you see, whenever you study fluids, there are basically two things to that. One is a static fluid and one is a moving fluid, which is called dynamic fluid, right?
Yeah.
So most of the things that we are applying, like Archimedes principle, we are trying to apply that in a static fluid. Okay.
Okay.
Now, a very peculiar quality of a static fluid is pressure difference, right?
Yeah.
Because of height.
Mm-hmm.
Okay. So because of height, you get a pressure difference. For example, if there is a fluid filled in this container,
Yeah.
and you know that the atmospheric pressure is P naught, this is the atmospheric pressure. So this
Okay.
is the pressure that atmosphere exerts on us, right?
Yeah.
You understand what atmospheric pressure is, Khushi?
Yeah.
Okay. Why is it there on us? Can you tell me the reason? That what is that it is
Uh,
putting the pressure on
there's
us?
air particles that keep bouncing off everything, so they exert pressure on us.
So it's the weight of the air particles that is above our head. Okay.
Yeah.
It's not only they are moving. Okay. It's because the atmosphere is held due to gravity
Yeah.
towards Earth, and that atmosphere is imposing pressure on us.
Okay.
Is it making sense?
Yeah.
So due to that, we are experiencing atmospheric pressure. That's why when the
Do we not experience it from like sides or just from the top?
see, uh, see, it's all around. It's all around.
Okay.
But what happens from the side? If it is acting here, then it acts here also.
Got
So
it.
it gets
Okay.
cancelled out. But from the
Yeah.
top, when you're standing, it is definitely acting like this way. It can't act
Uh-huh.
from the bottom.
Yeah.
Is it
Give
making
me
sense?
one sec. The door's just going.
Yeah. Okay. Shall I continue?
Yeah, can you hear me? Okay.
Yeah, I can hear you. What happened?
Nothing. The thing was still beeping, so I've just gone and switched it off now.
Okay. So what I am saying, Khushi, right now is
Yeah.
that whether you take air or you take fluid, the concept of
Uh-huh.
pressure remains the same. Okay.
Yeah.
The pressure comes due to the weight. Because when you go for scuba diving inside a sea, you wear
Yeah.
a very hard kind of a suit, right, over the body. That
Yeah.
is to protect yourself from the water pressure. Otherwise, your body will get compressed.
So that's
That
why
is
it's
the
rho GH.
yeah.
Right then.
So as you go down, the body might feel a lot of pressure due to water. So you wear that stuff, right, to protect your body from that external pressure which has got increased, because we are exposed only to atmospheric pressure, and that
Yeah.
atmospheric pressure is being balanced by the blood pressure that we have in our veins. Otherwise,
Okay.
our body will simply crumble. Okay.
Mhm.
So that but our body cannot adjust to a higher pressure than the atmospheric pressure. We are not used to it. Okay. So if we are
Yeah.
going at the bottom of the sea, then what happens
Okay.
when we are at the bottom of the sea? This water column is weighing over me. Okay. As if somebody has put this over me. So I am carrying that over my head. And by carrying that over my head, I am feeling that pressure on my head. Right.
Yeah.
So in any fluid, what happens at a height h, you go. So if somebody asks me what is the pressure here, if somebody asks me what is the pressure here,
Mm-hmm.
तो यहाँ पर pressure आएगा P naught plus rho g h. This will be the pressure.
Okay.
Where h is the height of the liquid column, rho is the density of the liquid, g is the gravity.
Yeah. Height of the liquid itself, right?
Yeah.
Okay.
Okay, you got my point.
Yeah.
Huh. So this is how the pressure comes at that particular level. Now,
Yeah.
at different levels within a fluid, the pressure is different, right?
Yeah.
At different level, the pressure is different, right? So now I am coming gradually to Archimedes principle. Okay.
Okay.
Be very careful, because when I will be explaining you the Archimedes principle, simultaneously I will be explaining you the buoyant force. Okay. So
Yeah.
the buoyant force is a force that water applies or a liquid applies on a body to keep it afloat.
Okay.
Okay. So it is getting derived using the concept that there is pressure difference at different levels. For example, the
Yeah.
pressure here is lesser, the pressure here is more. Right?
Uh-huh.
Now, imagine this. A very important and a very interesting stuff. Let's say you have liquid all around. Okay.
Okay.
And when you have liquid all around, I am asking you to imagine a cylinder inside this liquid. Okay. Let's imagine a
Okay.
cylinder.
Yeah.
Now, cylinder is also made up of liquid.
Yeah.
And
You've gone like your voice has gone really
the
crackly.
surrounding of this cylinder inside is also. Okay.
Can you hear
What
me?
I'm doing, Khushi, right now is I'm trying to add
Hello. I think the connection just dropped. I don't know if you can hear me.
can we watch call on? Can we put on right now so that I would be clear? I mean,
Hello.
just give me your voice is breaking too. Am I audible now?
Yeah, I can hear you now. Okay.
I don't know what happened in between. There is some lag or something.
Yeah, something happened. Not sure.
Yeah. So what I was trying to say is I am imagining a imaginary cylinder
Okay.
floating inside the liquid. Okay.
Okay.
So this cylinder is also made up of liquid, but it is at rest. What does that mean? There is a weight of this cylinder acting, but this is hanging over there. That means the surrounding liquid is putting upthrust force on the cylinder.
Okay.
Okay. I know very well that the surrounding liquid is putting up force everywhere. But what is happening is this force is smaller, this force is larger. So the net force is coming as the upthrust force.
Okay.
And the sideways force were also there, but they were getting cancelled out.
Yeah.
Okay. So the net force out of these purple forces you are getting as the upward force. Fine.
Yeah.
Balancing the weight. Okay.
Yeah.
Now, if somebody asks you why that upward force is coming in, it is coming because of the level difference. At the top, the
Okay.
pressure is less. At the bottom, the pressure is more. That's why due to the level difference, this upthrust is coming.
Got it.
Making sense?
Yeah.
Now what happens? I replace this cylinder with a piece of wood of the same size.
Okay.
It's a very interesting story now. Okay.
Okay.
I know that this upthrust is equal to W of the liquid, weight of the liquid. Okay.
Mhm.
Now I brought a wooden log, and that wooden log is weighing lesser than that of the liquid. The liquid is heavier comparatively, let's say. Okay.
Okay.
The same volume of the wooden log is lesser weight than the liquid weight. Okay.
Mhm.
And what I did, I immersed I immersed that wooden log in spite of the water cylinder. So this red color thing is getting replaced by the blue thing, which is a wooden block.
Yeah.
Wooden block. And this wooden block is having a weight, let's say W dash. Now,
Okay.
the water which is surrounding this wooden block is unaware of the fact that in spite of water being there, there is a wooden block now. They are just
Yeah.
doing their work.
Mhm.
So they are applying the same upthrust. Are you getting the idea?
Yeah. Got it.
The same upthrust was being applied. So if W dash is lesser than W, then F upthrust will be more than W dash, and this wooden log will come out.
Got it. Mhm.
This is how things are working.
Mhm.
Okay. So the water which is surrounding any body is unaware of the idea that where we are applying force is body or is water only. Okay, they are doing
Yeah.
their work. They're just doing their work, and they are doing their work because of pressure difference.
Okay.
Okay, because here the pressure is less, so less force. Here the pressure is more because it is a lower height, so more
Mhm.
force. As a result, you are getting a total upward force. This is called the
Yeah.
buoyant. Is it clear?
Okay. Yeah. Got it.
Called the buoyant force actually. Okay, and this is what Archimedes said, that if you immerse a body in a liquid, then the liquid will exert an upward thrust on the body equivalent to weight of the water displaced by the immersed portion.
Okay.
Weight of the liquid displaced by the immersed. What does this mean? Let's say you have this body which is immersed in a liquid to this extent, and let's say this is a volume V dash. This density is rho L.
Mhm.
Okay. Now, what is the buoyant force on this body? This V dash is this volume only, this volume. Okay. So it will
Okay.
be rho L V dash G. This is the up thrust, or you can call it as a buoyant force.
Mhm.
Are you getting it?
Yeah.
So basically, it was depending on how much part of that body is participating inside the liquid. Okay.
Okay.
That much liquid was there initially before the body came in. Okay.
Yeah.
And that liquid was being balanced by the surrounding liquid actually.
Okay.
Okay.
And what
So,
about the weight? How do you calculate that?
but when this body came in, that surrounding liquid is unaware of the idea that this is a body or liquid. Okay. So it is doing his work. He's simply applying the upthrust force depending on how much this body is participating inside the liquid.
Got
And
it.
the weight of the body will be calculated based on the volume of the body and the density of the body. So the weight of the body will be volume of the body, density
Yeah.
of the body into G.
Oh, okay.
Okay. Now, if the upthrust is equivalent to this, then it will keep the body afloat there.
Uh-huh.
Okay. If upthrust is more, then it will probably come a little outer then. Okay. It won't sink to that extent. Sometimes it happens, you take a plastic ball and you dip it inside the water. It does not remain inside, it rather comes out. Because what happens? The upthrust is quite larger than the weight. So it simply bounces up.
Okay.
So the idea is you need to chase that how much volume is immersed in the liquid, how much volume, and in what liquid it is immersed.
Yeah.
Okay, based on that, you will get a balance.
Okay.
Now, in your book, do you have some problems over this? You have some questions, or should I give you questions over this?
The book has questions, but they're not like that difficult. They're like really basics, and I think harder things are going to come up in the exam.
The harder things will come up in the exam. So are they giving you some certain other questions also?
No, my school haven't given me anything. That's the problem. We don't get much practice here. You just get told the concept and expect to be able to do it. So
Okay. So should I give you some tough questions here?
yeah.
So let me give you some questions here. Let's say you have got you understand what relative density is?
No, but
Huh?
no, no.
Relative density is density of a substance divided by density of water. Okay.
Okay.
That is why the word relative is being used, because it is being with reference to some other density. Okay. The relative density. So one thing is damn sure, that relative density is a ratio. Okay. For example, if I say that relative density of wood of X substance
Yeah.
is, let's say, 0.8. What do you understand by that? What will be the real density of X then? This is the relative density. So it is 0.8. Fine. That simply means rho of substance divided by rho of water is 0.8.
Okay.
Right?
Yeah.
Rho of water upon rho of substance upon rho of water is 0.8. Now you know what the rho of water is. If in gram centimeter cube I find out, it will be 1 gram per centimeter.
Yeah.
If in other way you find out, it will be 1000 kg per meter.
Yeah.
Okay. So now what will be the density of substance? Two answers to this. One is 0.8 gram per centimeter cube.
Yeah.
And the one can be like 0.8 into 1000, which is 800
kilograms
kg per meter cube. Making sense?
Yeah.
Okay. So my question goes like this. You have a cube. Let's say you have a cube. And this cube is 2 cross 2 cross 2 cross 2 meters.
Okay.
And this has a density of relative density of 0.75 relative density. You immerse this cube in water.
Okay.
Okay. We immersed this cube in water. Okay. So
Yeah.
how much of the edge will dip inside the water? How
Okay.
much of the edge will dip inside the water? Go ahead.
So, okay, so the volume of the cube is 8. Is that meters? 8 meters cubed?
Yep. But I am
Okay.
not giving you any hints further. You proceed by yourself. Okay.
Okay.
You are free to proceed. And you can let me
Then,
know that whether the cube will sink, whether it will float.
okay. So density is 0.75, let's say grams per centimeter. We should probably go kilograms. 750 kg per meter cubed. So if I calculate upthrust now, which is density of water, it is in water, yes. Density of water multiplied by volume submerged, which we need to find, multiplied by G. I'll take G as 9.81.
And you do it in the doable format so that you can send the solution on the Telegram or on the WhatsApp right now.
Okay, yeah. So this is 1,000. Should I take G as 9.81 or 9.8?
G is take it as 10. I'm giving you as 10. Don't
Okay.
take it as G, take it as 10 meter per second.
Okay, cool. Is equal to density of object. So the cube is gonna sink.
It will sink. No
Yeah.
way. It can't. It has a density lesser than that of the water. Yeah.
Oh, what have I done?
Sink? Something which is lighter than water should float, but with some of
Yeah.
its parts dipped inside, right?
Yeah. Okay, let's do this again. I do density times G times volume is equal to is it 3/4? So this is 1.75 meters.
Okay, yeah, that seems a good number. So what will happen?
So we have to make the upthrust equal to the weight because that's when it stops sinking.
Very true. Very true. Very true. So weight is like 2 cross 2 cross
Yeah.
2 into rho of solid into G. Let's say I'm not putting rho solid right now. And let's say the X part of this cube is getting submerged in the water. Okay. So what will be the upthrust? The volume that is getting submerged is 2 into 2 into X, because 2 into 2 is the base area and X is the height, right? So it will be 2 into 2 into X into rho W into G. Is it fine, Khushi?
Yeah, yeah.
This is upthrust. And let's say it is floating, must. Okay. Now I am equating them. So why I am equating them? Because I am trying to prevent you from the tedious calculation that you are doing. Probably you are putting rho s value, you are putting rho w value. No need.
Yeah.
No
Okay.
need. Okay, that's why my approach is do maximum problem solving in terms of variables. In the end,
Yeah.
try to put all the values.
Okay.
Now what you will do, you will say 2 into 2 into x into rho w into g is equal to 2 into 2 into 2 into rho s into g.
Okay, I see what you've done.
And 2
Okay.
into 2 got cancelled out. And I know
Yeah.
that rho s by rho w already is given to me as 0.75. So x comes out to 2 times 0.75, right? So 3/4 of the length will get submerged.
Yeah.
Of the length, right?
Yeah.
Now what is 3/4 of 2? Which is 3 by 2, 1.5.
Yeah.
So it is 3/4 submerged and it will keep on floating like that.
Yeah.
Does it make sense to you?
Yeah. Got it.
Okay. That is how things takes place here. That is how the part is. Okay.
Okay.
Now let me give you a good question from Buyoant Force. It's a good question. Like, you know what a cavity is? Have you ever experienced cavity in your teeth?
Yeah.
So what is the definition of cavity?
Like a hole or something.
A a a, a space filled with air closed from all the sides. That is what a
Yeah.
cavity is. Okay.
Okay.
It could be a circular cavity, it could be a rectangular cavity, doesn't matter.
Hmm.
Okay, so I have got a steel ball. Let's say I have got a steel ball and it has got a cavity in it, and there that is the part where the material is filled. The inside it is hollow, so there is air all around.
Yeah.
Okay, and the relative density of this solid part is 1.2.
Okay.
Where the things are being where the material is being there. Otherwise inside it is air. Fine.
Yeah.
And I am calling it as relative density. Okay, so you could very well relate that it is heavier than water, the outer part at least, right?
Yeah.
So if I want to keep it afloat in water, right,
Yeah.
then is it possible for me to keep it afloat in water somehow, or is it not
Yeah.
possible at all? That is what I want to ask.
It is possible.
Okay, so tell me the now I'm coming to the right question. Just give me a second.
Okay.
The question, Khushi, here is, let's say this is radius r. Okay.
Yeah.
And let's say the material that is filled over here, this is thickness t. This
Okay.
thickness is given as t, which is very small. It is a very good question that I am framing right now. Okay. Hello.
Okay.
Find the relation between r and t such that this ball floats in water with half part submerged. Making sense?
Yep.
You're finding it really difficult, right? I could sense it from
Yeah.
your
The
the
tone.
the tone. Yeah, exactly.
So you don't even have to see my face.
That is, my ears are also equally sensitive actually, right? After all, so much of experience I have, no, right?
Yes.
So Khushi, it's a actually I'm not thinking from that perspective. I'm thinking from the perspective when you will be inside a university. It won't be
Yeah.
like teacher will say you this and that will help you out. What will help you out is whatever minimum you know, how 360-degree you can think of and you can apply those things. Okay, so it's a
Yeah.
very practical thing. Now imagine this ball is made up of some heavy material. Okay,
Okay.
and we are trying to float it on the water. Okay, based on what? Based on the air filled inside it. Okay,
Yeah.
so if somebody will say me, sir, is it possible? Yes, submarines sometimes comes up, right? Haven't you seen that?
Yeah,
Haven't you
ships
seen this?
float.
Haven't you seen a large ship which is floating, right?
Yeah,
So it's not like if it is made up of heavy thing, it can't float. It can, but that depends on the structure, which is
yeah,
very much important for a mechanical engineer.
yeah.
So go for it.
Okay. So basically, I have to make sure it's
Hmm.
half
And
what?
neglect the weight of the air. Okay.
Okay.
You have to make sure that whatever weight is there is in the periphery. Fine. So
Yeah.
first of all, you have to make an estimate of that. And
Mhm.
that weight should be balanced by half of the ball getting submerged in the water. Okay.
Yeah.
So you have to make a balance of the two. So make a proper diagram and try to work it out.
Okay. So volume submerged is a half of the total volume. I worked out what the density of the object should be.
Sorry.
I worked out what the density of the object should be.
Density was already given, Khushi.
No, of the whole thing, like average overall.
No, don't do that. Air का density zero है. मैं बोल ही नहीं रहा ना air में weight है. I'm calling it as vacuum inside. Okay. Don't
Okay.
consider anything outside. अभी air कहाँ से तुमने consider कर लिया? Why are you considering air? When I come in
Right.
flow, I speak in Hindi. Sometimes things happens like very intuitively, then Hindi comes out.
Okay. So I need to
Okay.
consider.
I hope you didn't understand what I said.
I understand Hindi.
Oh, okay, okay.
You have a problem now.
Ah, I have to keep a check over the in this thing, right? Which
Yeah.
comes out, right? Hmm. So Khushi, what I am expecting ki this kind of diagram we will make. Okay.
Yeah.
And you know what? I have given you thickness T, which is very small. So
Mhm.
this part is displacing some water, and this volume I know is 4 by 3 pi r cube. Half of the 4 by 3 pi r cube.
Yeah.
Okay, because 4 by 3 is pi r cube is the total volume. Okay,
Yeah.
and this is the volume. This getting multiplied by rho L into G. This is the upthrust I am getting.
Yeah.
Did you get my point?
Yeah.
This is the upthrust that is being applied by the liquid on the body.
Yeah.
And now this body has a certain weight, which I am drawing by black color. And I am drawing the upthrust by the purple color, in the color with which I have calculated the value. Okay. But for body to be stabilized, both has to be equal. Now, weight depends on what volume is filled over here. Okay. Now, this is
Yeah.
the core idea. Can you let me know what this volume is, Khushi? This thickness T is small. It is given, it is small. So there you
Yeah.
have approximation. Suppose you take this sphere and you cut it out and you spread it all over. It will be like a sheet.
Yeah.
Let's say it is made up of foam. Okay, let's say it is made up of foam. And you cut that foam out and you spread it over the planar surface. It will be a thicker sheet of thickness T. Fine.
Yeah.
So you know the area, the above area is 4 pi r square and the thickness is T, right? This will be
Yeah.
spreaded out like a foam like this whole thing.
Yeah.
T is the thickness and this is the area, right?
Yeah.
So I can very well say the volume will be 4 pi r square into T. This is the volume of this portion.
Yeah.
And if the volume is known to me, I can multiply it by rho s, which is 1.2. So rho s is the relative one. Rho s is the density of the solid into G. That will give me the weight.
Yeah.
Is this approximation clear?
Yeah.
I can only apply this approximation when T is less. Otherwise, what I have to do, I have to get the outer volume minus inner volume. 4 by 3 pi r out ka cube minus 4 by 3 pi r in cube. Okay, to get
Okay.
particular volume. But when the T is small, I can apply this approximation
Okay.
by considering it to be a flatter sheet.
Yeah.
Making sense?
Yeah.
It will be like 4 pi r square T into rho s into G. Okay, this is the weight.
Yeah.
Now when you equate this weight to this, you know rho s by rho l already is given as 1.2.
Yeah.
So bus, that's all. That's how the things will work out. Now I will put this part over here, which is 4 by 3 pi r cube into 1 by 2 into rho l into G. Clear?
Got it.
Now 4 pi and 4 pi will get cancelled out.
Yeah.
Okay. G and G will get cancelled out. Then you have got r square here, you have got T here, you have got rho s here. Everything got cancelled out, right? Then you have r cube here, you have got 4 pi, 4 pi, you have got 6 here, you have got
Yeah.
rho and you have got G here. Okay? Rho s by rho l is 1.2, that you know.
Yeah.
R square से ये cancel हो गया. So it is T times 1.2 is equal to R by 6 into G. Acha, G thing got cancelled out. Na? G to I should not have carried. This is the relation between R and T.
Okay.
Isn't it interesting?
Yeah.
So this is how you made it float. Like maybe you worked out the average density based on, you assume that something is filled inside.
Yeah, I did.
That needs to be avoided right now. Agar wo hota, to that weight should also be considered by us.
Yeah.
Okay, then there would have been an additional weight in spite of this, which is just the weight of the solid contained within the boundary.
Okay.
Okay. So I think a better vision of band force you have got through.
Yeah.
Is there any other concept that I wish to discuss on so that we can practice numericals at the end? Is there any concept?
No, I think buoyancy was the only concept I was struggling with. I just have to practice now.
जब भी टाइम मिलेगा गद्दा चाहिए
हाँ, अच्छा तो ले लो
नहीं हम भूल गए और स्टाफ को भेज दिया अब आपको हेल्प करनी पड़ेगी
हाँ तो मैं तो
तो जल्दी नहीं है जब भी तो करना
हाँ
और बाकी लोग बुला रहे हैं तेरे को मिलने के लिए
हाँ
तो तेरी क्लास कब तक चलेगी
12:30
हाँ चलेगा अभी कितने बजे
11:40
41
sorry Khushi.
Alright.
Okay, what you were saying?
No, I said that was the only concept that I needed to.
Okay, that was the only concept. Okay.
Yeah.
So what I did, I have worked out some problems from this material section, right? We can have that. We can have those problems, right? And we can get going by those problems, right? At least we will have an idea that how we are applying the concepts. Okay. So you know that materials is having a really low weightage, right?
Yeah.
Okay. Now this is the 36th problem. That is
Can I
one
see the
of
weightage of each thing?
the weightage is.
What's the most weightage?
Though that was, I already told you, this was the section 1 of Cambridge, right?
Mm-hmm.
This is a section 1 of Cambridge. You could see the most weightage geometry, this mechanics 55,
Oh yeah,
the part that you loved the most.
that's good. I'll take it. Then geometry. Oh no.
Where is
Don't
the
like
moment
geometry.
thing? Where is the moment thing? The moment thing is in the mechanics only, right?
Yeah.
I
There's also
expected
geometry. I don't like
yeah.
geometry.
You like geometry?
No.
You don't
I
like
can do
geometry.
it. I just don't enjoy it.
And they see the electricity also has a weightage of like 18.
Yeah.
So it is based
Algebra.
on the analysis of 4 years of papers, like
Wow,
2016
okay.
to. Is it clear?
Yep.
So let's start with the first question of the material, and I'm expecting an answer from you. Is it visible, Khushi?
Yeah, I can see it.
After it is all done, I will send this directly on your Telegram account once you install that.
Okay.
I hope you will do it today.
Yeah, I'll do it after this.
Yeah, no problem.
What is this strain? Okay. Everything G is 10. Okay. Never mind.
Is this concept you're familiar with?
Yeah. This I know.
Okay, I'm sure that you'll come out with the right answer in the very first part.
I mean, we'll see. We'll see.
See.
No, I said we'll see if I come up with
Oh,
the right
we'll see.
answer.
I'm very sure. Don't worry.
You might be too sure.
Yeah.
Is strain the same strain as the equation, stress over strain?
Yep.
'Cause I know
Uh, the strain energy in the wire, half stress into strain into volume is the formula for that.
I did not know that.
See, when you stretch something, when you stretch a spring, that stores some energy, right?
Yeah.
Similarly, when you have a rod and it is obeying Hooke's law, if you subject that rod to a certain force, it gets stretched out, right?
Yeah.
So it has got a certain energy in it, no?
Mhm.
वो हो जाएगी half stress into strain into volume. That is the energy. That was not known to you?
No.
Okay, acha, do you know spring energy, Khushi? Half kx square.
Yeah.
Okay, let me do this working for you. It will be an eye opener kind of a thing. See, let's say you
Okay.
have a spring, okay, and let's say
Yeah.
the length of the spring is L0, which is the natural length. Okay,
Okay.
so at natural length the spring is not stretched, right? Now
Yeah.
what you do, you are stretching this spring to a length L0 plus x, and
Okay.
this spring is having a spring constant k.
Yeah.
You have a spring constant k.
Yeah.
Spring constant is K. So the energy stored here will be half K x square.
Yeah.
Making sense?
Yeah.
Now I am comparing, and one more thing is there, Khushi. The force that is acting on the spring is K times X, which where X is the extension.
Yeah.
I think you are aware about these two formulas, right?
Yeah.
Now you take a rod in spite of the spring.
Okay.
And when this rod is subjected to some force, there is a change of length from L to L plus delta L.
Yeah.
Okay, this is F. Now, how will you write the equation? You will write the equation as F upon A, where A is the area of cross section, divided by delta L by L is equal to Y.
Yeah.
So you will get F is equals to A times AY by L times delta L. Is it
Yeah.
clear?
Yeah.
This particular thing, this is acting like K. See, can you feel that? The X is the extension, no?
Yeah.
Isn't it?
Yeah.
So this is the extension delta L. This
Yeah.
is the force. This is the force. This is K. This is K stuff. Is it making sense?
Oh, yeah.
Things are very relatable in physics, right? It's not you
Yeah.
have to learn everything.
Huh.
I don't remember anything actually. So what is the energy now? The energy is half K into delta L square. That is what the energy meant to be in like in spring. If I'm writing it half Kx square, I know that this is acting like K. So I'm taking it as K. And the extension
Yeah.
means to delta L to me, right? Fine.
Yeah.
That is what he's expecting from you. Okay.
Mhm.
Now, this thing can be expressed in a polished format. This is one of the format. Okay. This is what he was expecting from you, that how much energy is stored. Okay.
Yeah.
Because when you have extended it, the molecules have moved and there is
Yeah.
some potential energy stored in the intermolecular force format.
Yeah.
Okay. Because the molecules were at a certain distance, when they moved up, right, there is some energy that is getting stored.
Yeah.
Okay, so this is the energy. Now I will give this energy a certain form which you can remember. Okay, wait and watch. Like half stress, okay, half stress into
Okay.
strain into volume. Half stress into strain into volume. So again, half,
Okay.
what is stress? Stress is F by A. What is strain? Strain is delta L by L. And what is volume? Volume is L into A.
Yeah.
Approximate volume is L into A. I know the new length is L plus delta L. I'm ignoring that delta, right?
Yeah.
Now you see whether this thing is resonating with this thing. See, delta L, what I'm saying, half stress into strain into volume. Okay.
Yeah.
So now I'm getting A. Achha, I'm not getting Y. Anyways, I want a Y. How can I get a Y? By using this. By using this. है ना?
Yeah.
मैं किसको रिप्लेस कर सकता हूँ? F L by A को. F L by A को मैं रिप्लेस कर सकता हूँ Y into delta L.
Yeah.
F L by A can be replaced by Y into delta L. Fine. So I will
Yeah.
get half Y into delta L into delta L by L into A. So you got this AY by L. You got
Yeah.
delta L ka square. You got the same thing. See,
Yeah.
you got the same thing, no? AY by
Yeah.
L, AY by L, delta L square, delta L square. I'm not tricking you. These are the normal things. And I don't feel like being tricked. Okay.
Yeah.
So this is the energy stored in the extended part. And I don't remember anything. I simply compare this rod with the spring. That's all. I know these two basic equations. And whenever
Yeah.
I work it out, I compare them. That's all.
Okay.
I think now you can work that out, work that question better now.
Yeah.
Now, for sure, you will get the answer.
Yeah. Okay.
Try it.
Where's the okay? Stress then is 40 divided by 2 times 10 to the minus 6. Is it F?
Now, if you're getting an option, then definitely it must be there, no?
Yeah. I mean, they
अरे
do that on purpose.
ना 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 तुमने कुछ गड़बड़ किया है. हाफ भूल गए क्या तुम?
Yeah, I forgot the half.
हाँ?
I forgot the half.
Ah.
You are correct.
So that was a very good guess that I made, no? You
B.
forgot half.
Yes.
अरे यार ऐसे मत किया करो. Fine.
Yeah.
Chalo, so there is a new learning today in terms
Mhm.
of buoyancy force also and in terms of energy also. Okay.
Yeah.
Okay. Now, what is this? This seems to be a tricky one over.
Yes. Okay.
Let's see. Try it out.
Okay.
Okay. So he's talking about alloy, which is very much important in material science.
Yeah. I think I can do it. I think.
Yeah, you can do it, Tim. Even I'm sure about it. It's a general calculation based question, actually.
Yeah.
Right.
Is it G?
Sure.
Yes.
Will I lock it?
Yes.
Yeah, it's G.
Okay.
But you didn't win anything, right?
Oh.
It's G, right? Fine. So you see, there are only 2 questions that came out, right?
Yeah.
Among 4 years, so not very important, but fine. Let's see the section 2 now of the Cambridge part.
Okay.
And there are about, like, you see, in this there was comparatively 4 questions that came out in 4 years, right?
Yeah.
And on an average of 1 question per year.
Yeah.
And you see the part 2 is dominated by, again, mechanics and electricity.
Yay.
That is what part 2 is dominated by.
Yeah.
Go ahead. 18th.
All right.
Yeah.
Is that 8 times 10 to the 8 on the top? Or is it
Okay,
9?
it's 8 into 10 raised to the power 8.
Okay.
It's very small, no?
Yeah.
It's 8 into
Yeah.
10 raised to the power 8. Yeah, go ahead.
Got it. Okay. Is it B?
Mm-hmm. It's the answer is B. Wow, perfect.
Nice. I
Great.
didn't forget the half this time.
Oh,
I think
okay. They were using that formula. Okay, work done, right?
I use the formula because it's the same as energy, but I don't know.
Yeah, that's fine. The whatever
All right.
work is done is getting stored as energy. That's all.
Yeah.
Okay, so whatever we learned today is being used twice, right?
Yay.
चलो देखो इसको. Don't you get tired in such a long school hours, Khushi?
It's okay. I mean, after I come home and do this too, I get really tired. But school itself is fine.
Okay. It's too long actually, 7 to 5. Right?
It's not 7 to 5. I leave the house at like 7:15, but
Oh,
school starts at 8:40.
acha, so it's far away.
Yeah, around an hour. I take
Oh,
the train though, so it's faster by car.
you take a train.
Yeah, 2 trains. So my answer isn't actually on the list, which means I've done something wrong.
Yep.
Okay.
Okay. See, there are 4 steel cables. Okay. So
Yeah.
probably I could see maybe you have taken that net tension as wrong, right? Because
Maybe I didn't multiply by
power is
4.
F dot V, that you know.
Yeah.
Force is a vector, velocity is a vector, and then you do the dot product to get the power, right?
Yeah.
F vector dot V vector. It opens as
Yeah.
mod F mod V cos theta, right?
Yeah.
So what I'm saying is maybe you have taken the force value as tension value only, isn't it? Whatever you are
Yeah.
getting as answer is the 4 times of that is in the list. Just check 4 times of that.
I have 10 kilowatts, 4 times of that. I think I divided by something wrong in the middle. Let me just redo
Have
it.
you converted the area to meter square?
Yes.
2 into 10 raised to power minus 4, right?
Yeah.
What is the tension value you are getting?
I was doing strain. I was trying to find stress so I could get the equation for force.
You were trying to find stress.
Because we're given Young's modulus, and
That
I
is
know it's
fine.
stress
And
over strain.
through stress, arrive at tension. No, arrive at tension through stress. T by A is stress and T is tension. Arrive at the tension, okay, and then do
Yeah.
T dot V, 4T times dot V, because there are 4 strings, right?
Yeah.
So you have to be careful that you have to find out total tension is 4 times T, where T is
Yeah.
tension in one cable, right?
Yeah.
That is how you should go about it. So where's this problem coming in?
I think when I'm trying to do the equation, I don't have the volume because I don't have a length. So I
See,
can't. I'm
you
messing up
have
somewhere.
strain, you have strain value, okay?
Yeah.
You have Young's modulus value, you will get the stress, fine.
Yeah.
Once you get the stress, multiply it by the area, you will get the force, which is tension.
Oh, got
Why
it.
do you
Got
need
it.
the volume and all, yeah?
That's smart. Okay.
It's a jugadu technology. You understand that word?
No, but it
You
doesn't
don't
seem.
understand that jugad word? Jugad.
No.
It's a filthier form of being pragmatic. Okay, filthier.
So then it's just D.
Okay, it's just C or D.
D.
They are giving C.
Okay, hold
Now
on.
again, you missed out something over.
Stress would be 2 times 10 to the 11 multiplied by
Okay,
0.0025.
but the area is in centimeters square. No?
Yeah, so then I multiplied that by 0.0002 and I got 100,000 watts, which should be D. Oh no, wait.
कुछ गड़बड़ कर रही हो यार.
What have I done? Multiplied by 4. No, I got what I did wrong.
क्या कर दिया?
I just didn't multiply by the velocity because we didn't really use that equation that much, so I'm not used to it. Force times velocity.
Khushi, in your book, they are giving the energy over there as half F into X. Okay, they haven't given that formula. I was just surprised. I can't
We've
see
done
that
it
formula.
though.
Huh?
We have done the formula at school,
Half,
but
no,
we
that
were
formula,
looking.
half stress into strain into volume. That formula you have done?
Oh, no, that we haven't. I don't think it's in the syllabus.
Yeah, that
It
was not
might.
there in the book even, right? I'm just
Yeah.
looking at the book right now. I can't find that formula to get the energy thing. For the spring, it is written as half kx square.
Yeah,
Okay,
that's the
but
one.
they haven't mentioned it for some other rod which is behaving elastically.
No, they haven't. We haven't done that. I don't think it's in our A level spec. It'll be in the ENGA though. It won't be
It will be
in the ENGA and the Cambridge assessment, but it won't be in school.
yeah, it was there. It was there.
Yeah.
It's fine. So what is the final answer for the 10th one?
C.
Okay, so
I got
finally
it in
C
the end,
arrived.
yeah. Yeah.
Good, 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 good. This is done. This is done. Now 2 more to go. Have you practiced some Enga questions previously also?
I have, but I've done mostly maths because I do
Maths.
maths out of
Okay.
school too. So
Fine, fine, fine. It's fine.
is it F?
देख लो एक बार check कर लो before I check. You don't want to check?
I mean, I'm checking now.
Okay. I will suggest you check it once. Some calculation part.
Okay. I may not be doing it correctly.
Yep. It has got good enough data, no? So maybe the conversion and all goes.
Maybe. Let me just
Yeah.
check it again. I think it's just an error in understanding then, because I can't see where I've gone wrong.
Is it a conceptual understanding that you are lacking on?
Maybe. I haven't done this sort of question before.
No, that is fine. That is fine. Two identical springs each have an unstretched length of 12. That means that is a natural length, right?
Yeah.
And they are of negligible mass, right?
Yeah.
Now, one of them is hung from a fixed point. 100-gram mass is being hung lower end, fine. Second spring attached to the base of the 100-gram. Okay, so it is consecutively held, right?
Yeah.
One spring here, then there is a mass, right? Now the
Yeah.
second spring is attached to the base. A second 100 kg is hung at the lower end, right?
Yeah.
Fine. Now you see these the bottommost spring has the responsibility to carry the lower load, right?
Yeah.
So it will have a force which supports 100 grams, right?
Mhm.
There will be a stretch in that spring corresponding to that force, that
Yeah.
load. And the load that is there in the topmost spring is supporting 60 gram.
Yeah.
So there will be a stretch in that spring that supports total 200 grams, sorry, 200 grams.
Okay.
Is it making sense to you?
Yeah.
The topmost spring is under severe stress because it has to support the two blocks, no, one here and one at the lower part, which is pulling it, right? So
Yeah.
so the stretch in the above will be more, comparative to 400 grams. In the lower
Yeah.
one, it will be comparative to 200 grams.
Got it. Okay.
And now you can work it out separately. Like the stretch in the upper one is x1, the stretch in the lower one is x2. Their addition is 30. Okay. And what that stretch will be in terms of force, like kx1 is corresponding to 400 grams. Kx2
Yeah.
is corresponding to, kx1 is corresponding to 200 grams. Kx2 is corresponding to 100 grams, right?
Yeah.
So you know
Yeah.
their ratio, you know their addition. You can get the separate values.
Yeah. Yeah. I got it.
And where once you know the separate value of kx1, you know the x1 thing, then you know
Yeah.
that kx1 can be balanced to 200 grams. You can get the k thing.
Mhm.
So
I
first
can
get
get. Yeah. I know how to get it now. Okay.
yeah, you'll do it. Do it in a doable format. Okay, so that I can check.
Okay.
Okay.
I mean, I'm still not getting an answer that matches up with anything.
Yeah, that should not happen, Khushi. Can you send me on WhatsApp what you did? You're working. I want to see your working.
Okay.
Yeah, please.
Not sure what I've done is correct or not.
The combined length. Oh, the combined length is 30. So I am x1 and x2 should not, x1 plus x2 is not 30. x1 plus x2 should be equal to 6 actually, Khushi.
Yeah, I
That is
did
the
that.
You did
But
that?
it's not. Yeah. It's
You're
still
smart
not
enough.
right.
Smart enough.
Yeah.
Just send me. I want to check.
I've just sent it.
Okay. Let me see. You have got kx1 equal to 2. That is supporting 200 thing.
Yeah.
So that is fine. And you got x1 plus x2 equal to 6.
Yeah.
एक
So
मिनट.
I tried substitution.
ना ना मैं समझ गया. x1 by x2 किया तुमने. मेरे को लग रहा है there's something wrong with the solving thing happened, right? It is not that ये quadratic बनेगा ही नहीं खुशी. See, x1 by x2 is 2, right?
Mhm.
So you directly put x1 as 2x2, no? Why are you doing this much here? You got first equation as 2 equal to kx1, fine.
Yeah.
You got second equation as 1 is equals to kx2. Divide them. You will get x1 by x2 is equal to 2.
Oh, I see. Okay.
अरे यार ऐसा मत करो.
I've never done it like that.
x1 by x2 is equal to 2, right?
Yeah. Okay.
So x1 को 2x2 निकाल के put करो. You will get 3x2 equal to 6. So x2 will come out to be 2.
Yeah.
You
So
made it a
x1 is
little more
4.
complicated while solving.
I've never ever divided simultaneous equations before.
Oh, actually, you see, Khushi, when there are like ratio things coming up, no, then this, see, my idea was to remove k actually. You see this. So
Yeah.
removing k can be easily done by dividing actually, right?
Yeah.
So you should try to remove as much as variables as possible. Actually,
Okay.
that is the idea behind.
Okay.
Yeah.
Okay. So then K is a half. E.
K is gone. You got x1 by x2 as 2. You will get x1
Yeah.
and x2 now. Yeah. Now you will get the answer. Do it. You'll get the answer.
Yeah. So K is E. A half. Right?
Hmm. K is gone. X1 is 2x2. So I got 3x2 equal to 6. I got
Mhm.
x2 equal to 2. Okay. And x1 equal to 4. That is what
Yeah.
I got. Now kx1 is not equal to 2. You have to, the answer is given in Newton centimeter inverse. That is also, we have to be very careful. We are generally calculating the thing in SI units for K, which is Newton meter inverse, but the answer is given in Newton centimeter inverse. Okay. So now you will equate kx1 equal to 200, 200 grams. So 200 grams will become 200 by 1000 into G as kg. Okay.
Okay.
You convert that to kg. Okay. And keep x1 in centimeters so that you can get the final answer in Newton per centimeter for the K thing. Okay. So kx1 you have written as 2. It is not 2. It is 200 divided by 1000 into 10. Okay. That comes out to be 2. That's why you have
Yeah.
written 2 over there, right? Okay.
Yeah.
Now what is x1 coming out? X1 is coming out to be 4. Okay.
Yeah. So K is a half.
Yeah, that's all. E is the
Yeah,
answer.
that's what I
0.5.
said.
But initially you said something else.
Oh.
Initially, I think you gave some other answer, no?
Yeah, originally I said F, I think, but that was before I knew how to do it.
Okay. Right now you said E only.
Yeah.
Okay, fine. Next question. I think that this is the last question. Or yeah. Which sample? Okay. There are 3 questions based on this. D. Show your workings in the space provided. There are still many of these questions there. Okay. Let me take this question now. They are asking like various questions out of this comprehension. Actually, it's a comprehension.
Yeah.
Just read through. Which
Okay.
of the samples is the stiffest compared to the other samples? The one which is stiffest requires
It's
larger force to get the same elongation, right?
so it's S1.
So answer is S1, right?
Yeah.
Very clear. Yeah,
Yeah.
perfect. Now, which samples does not obey Hooke's law up to 2% strain?
Okay.
Up to 2% strain.
So 2%
Yeah.
is, let's have a look. It looks like S2.
नहीं देखो, the overall length is given as 100 mm, right?
Yeah.
So for S1, the Hooke's law is being obeyed till like 2 mm, right? So 2, that is 2%, right? S1 is exactly 2%. You see, it
I
is
thought
2
that
mm.
looks
No,
more like 2.5.
for S1 you are saying?
No, I'm saying for S2.
Okay, for S2 it is comparatively more. So which
S2
of these
looks like
samples
it's
does,
not straight. Yeah.
and S3 is it obeying? S3 is it obeying?
Yeah. Everything else is obeying until 2%, but S2 is curved.
Okay, but until 2% every one of them is obeying,
Yeah.
right? So S2 is curved from the very beginning only.
Yeah.
Yeah. That seems like different, right? Yeah.
Yeah.
So, what value of Young's modulus of sample S3, assuming that changes in its cross-sectional are negligible? So he's
Okay.
asking Young's modulus for S3.
Yeah.
Now let me show you the graph.
Okay. Can I see the options again?
Yep. I have shown you the answer itself, right?
Oh,
There are four options. Go for it.
is it B?
अरे यार थोड़ा न गड़बड़ है. Shall I show you the graph again?
Yeah, I'd forgotten the values, I think.
Yeah, you have to get the values again. See,
Okay, I've noted down the answers, so I don't have to go back there.
yes, please.
Is it A?
Yep. Now you strike the right chord.
Well, I mean, you said it was only a small mistake too, so it's probably just the zero.
No worries, no worries. Now it seems a good question is coming out. See,
Oh,
is it a friendly question?
no, but I think it's doable.
That's fine. You can just note down the data and then if you need, I can go to the graph for you.
Yeah, one sec. Okay, you can go back to the graph.
I'll go back to the graph.
Yeah.
You have noted that question over there?
Yeah.
Okay. So Sunday, same time we can meet if it is fine. Or you want earlier?
I mean, if it's convenient for you, it's better to do earlier.
Sorry,
It's probably better to do earlier.
what time? Like for you, what's your time? Will it help you?
Maybe like 4 my time.
Okay. Yeah. So then it's 11 my time is what time at your place?
It's 5:30.
5:30, no?
Mm-hmm.
So 4 is like 1.5 hours before 11, right? So
Yeah.
that is 9:30 at my time, my place, right?
Yes.
Yeah, that is okay. So that you can have a free evening on Sunday.
No, I have a lot of work,
You
so
have a lot of work,
no free time,
no free time. It's a very difficult life.
I guess. Okay, I'm stuck. I don't know.
एक मिनट रुक जा. What is that made you stuck?
I
So
don't, I've
here,
got,
okay,
yeah,
here the force is given as a function of x,
yeah,
where force is variable. Okay, so you do f dot dx, f dot s karo, and then you integrate to get the net work done, because force is not constant. You cannot operate f dot s directly, no?
okay.
So you should know from where to where you have to integrate. Okay, that is something you should know. So he's saying that sample S2 breaks when its extension is 10 mm. X is the extension. So definitely nothing needs to be seen. Only thing is it has to be integrated like ax minus bx square dx from 0 to 10. But while keeping it over there, you have to keep it 10 by 1000. Okay,
Mm-hmm.
because you are putting the things in SI units. Okay, you are getting, see, the answers are coming in Newton meter. Okay, so
Yeah,
you understand this when a variable code comes in, like for a spring force is what, kx. Okay,
yeah,
so kx dx integration, that gives you half kx squared, no?
yeah.
You know
Oh,
integration
I
stuff.
was trying to find A and B because I didn't see the answers. I didn't realize we had to do it in terms.
Okay, you were like working too hard, then they were not expecting
Yeah,
that much. It's a 2 mark
I got
question.
an equation. I was like, how do I get the other one?
It's a 2 mark question. They're not expecting that much of hard work. You are used to too much of hard work, Khushi.
It's true.
Yeah.
Okay.
Is the integration done?
Yes, I'm just
Hmm.
double checking.
Acha, you want to be sure about your answer.
I do.
Very good. Good habit.
Especially because my answer's not on the list as of right now. But I think I'll get there. I messed up in it's just the tens. I got the A over 2 and B over 3.
Okay.
So it's obviously
Mhm.
10 to the minus something, so it can't be
10
C.
की power -6 आएगा, so it should be A, no?
10 to the
देखो
power
मैं तुम्हें
minus
बताता
6. Yeah,
हूँ.
I
So
know.
it's like x cube coming out there, and x is
Yeah.
10 by 1000, so 10 की power -6 has to come
Yeah, I
because
got.
x is 10 की power -2, right?
Yeah.
So the answer will be A.
Yeah. Got it now. I was
And
doing
x
10 by
square is 10 to the power -2.
10,000.
Yeah, that's all.
Yeah.
You became overconscious probably then.
I
Right?
did.
I know. Fine. So we did with material part.
Hmm.
Enga is something that we solved today. Okay. Let me know that what we need to do for our Sunday class. Is it like you want to practice some more problems on this, or shall I get to the energy wala part, because that is also coming in the test, no?
Yeah. Energy I'm okay with actually.
So
That's-
shall we practice the Enga problems of work, power, energy then?
Yeah, let's do that.
Let's do that, and some mechanics problems also.
Okay. Yeah.
Fine. Good enough. Okay.
Okay.
Okay. Let's close. Take care.
Yeah.
Bye.
You too. Bye.
Bye.